Hi, I'm Jerome, and I'll be presenting my work on multitask approach for explaining clarification questions in task-oriented conversational systems. So as an introduction, as you know, there's been a lot of research on chatbots in a number of domains like e-commerce, music recommendation, and general chit chat. So you can imagine things like Siri and Alexa. There's been a lot of focus on improving the models. However, because many of them are deep learning-based approaches, they are black box models and they're hard to explain to users. So the goal is for explainable AI to increase the user confidence and to help users make better decisions and faster and increase the ease of use of the system. So I guess as a related work in general for AI, there's been two different branches of explainable AI. So there's the inherently explainable model where the explanations can be generated during training. So there's a set-based approach and additive models as examples. And there's also post hoc explanation modules. So an example would be model agnostic methods like SHAP and LIME and counterfactual learning. And these methods happen post-training. So as an example, here we have SHAP values on the right, and this can be helpful for doctors because they see, for example, that age is a very important feature in this mortality model. So moving on to conversational systems in particular. So we worked with the SHARC dataset, which is a conversational machine reading task, which is a type of task-oriented dialogue system. So given a rule text and a user scenario, the bot must answer a user's question or answer an additional follow-up question. So in this example, at the top text, we have the rule text, and this is the sort of rules that are explained in a natural language text. And then some of the rules are implicitly written inside the user scenario. So a user might say they served in the army and they were never in active duty and so on. And then the bot also has a explicitly written dialogue in the dialogue history. So this is previous turns with the user. So for example, the bot asks the user if they are a veteran and they said yes. So the end goal for the bot is to either say yes or no to the user's original question. Does this program meet my needs? Or say that their question is irrelevant and cannot be answered to the rule text. And finally, it can also generate an additional follow-up question. And this happens if not all of the rules have been covered so that the bot can return a final answer. So here we have an example of one of the current state-of-the-art methods. This is the discern paper. So they highlight underspecified spans, which is mostly used for question generation, but these spans would not be a sufficient answer alone to explain. So for example, if it said, are you able to get financing from other resources? And the user says no, the bot just says yes, but the user doesn't know why. And this might be, in this case, trivial because all the answers are yes. But for example, if the user said yes as the follow-up answer for answer 2, the final answer would be no, and they'd want to know why the answer was no. So if you only return the bold text, which is the underspecified rule, it wouldn't be enough. So we want to extract all of the relevant parts of the rule text such that the user could understand what the explanation for the answer is. So an ideal explanation is highlighted in blue. So the model outputted, do you have a disability? And the user might ask, why do you want to know if I have a disability? And they could say, the bot would say, public housing provides affordable rental houses or apartments for people with disabilities. And as you can see, this is highlighted inside the rule text. So in order to gather those highlighted rule text, we developed a crowdsourcing application in Flask and JavaScript, and we sourced workers on Amazon Mechanical Turk to highlight parts of the rule text that could explain each follow-up question in the dataset. And users were encouraged to highlight complete sentences as these are more simple explanations for users to understand once it gets returned. So all of the highlighting was done for conversations in the publicly available Shark dataset, which is about 24,000 examples. There's also a private test dataset, which is used for the leaderboard performance, which I didn't have access to. So it's only for the publicly available training and test and dev set. So here we have a multitask model. So what I did was I tokenized the rule text question scenario and all of the follow-up questions using Roberta, and there are two tasks to be trained. So one is the original Shark data task of classifying the answer as yes, no, more, or inquire. And it's a simple feed-forward network. And then the second task is a multi-span explanation tagging, which I'll describe in a bit. So previous papers rely on single span highlighting because they are under specified spans, but explanations I saw in the previous example tend to be multi-span, so this technique wouldn't work. Therefore, we decided to treat the multi-span highlighting as an IO tagging problem, which is a common problem in named entity recognition. So each token in the rule text, once it's encoded using Roberta, is either inside or outside the answer. So we train the model to choose, classify each token as either I or O, and we train to minimize binary cross entropy and take the tag with the highest probability at test time. And then here's a gloss over this, but it's the question generation task. And this is generally trained separately from the decision classification task in previous models, because they found that training question generation and decision classification at the same time tended to worsen performance. Therefore, a second model was used. And this is similar to previous state-of-the-art models. So I'll just pass over that as there's no explanation parts there. So for the decision classification task, it compares fairly close to it. It's not quite at the same level as DGM, which is the current highest accurate task model in the Shark dataset. But as you can see, it's a relatively good performance. So if this were to be deployed in the real world, developers would have to weigh the trade-offs between accuracy and explainability. But overall, the overall accuracy isn't too hard from our model compared to DGM, especially given that the decision classification for our model is a simple feed-forward network, unlike some of the other state-of-the-art models which use more advanced techniques. So in the explanation task, we used EM and F1 to calculate the IO tagging task. So we could see those two benchmarks as well as a user score, which is manually asking annotators if they think that the explanation return makes sense or not for that given conversation. And then we omit F1 for irrelevant because there's no I tags to be tagged in ground truth. So it would default to 0. But a better case in irrelevant would be the exact match because it's either blank or it's not because there's no explanation for an irrelevant conversation. So overall, the metrics seem good, but a big problem with the metric is that F1 and EM don't really capture if the explanation is syntactically correct. So for example, if a couple of tokens were mistagged, it can lead to an answer that's a bit nonsensical in English because it's adding extra words or removing words that doesn't make sense, but it would still have a high F1 score because most of the tags were properly classified. So for conclusion and future work, so they perform reasonably well. So as I said before, a developer would in the real world would need to weigh the trade-offs between a couple more points in accuracy or a little less accuracy, but an explainable model. So there should be better metrics to compute performance of the extracted explanations, because as I said, EM and F1 aren't totally the best because they don't capture the meaning of the explanation. And of course, asking users to annotate if explanations are good or not is not scalable. So the quality of the explanation is also highly dependent on the structure of the rule text. So if the rule text isn't worded in a way that's easily highlightable for an explanation, it could not lead to a good explanation no matter what someone does. So a generative approach might yield better results. So rather than highlighting, we have a natural language processing model to generate explanations. And then another interesting future thing I may work on is, can we apply it to recommendation domain? So an explainable conversational recommender system. So yeah, that's it, and open to any questions.
Thank you very much. Time for one quick question. Yes, please.
In your Amazon Mechanical Turk experiment, how do you validate that Turkers are doing what they are supposed to do? You have control questions. How do you do it?
So I ran a couple. I ran, I guess, a small set of 100 Mechanical Turk just to see if their answers matched up close to each other for quality control. And I did see that the Turkers were doing what they were doing. So afterwards, I released a bigger set of mechanical work data set task for the whole data set. And then once that was complete, I ran a validation task for a separate group of crowd workers to validate whether or not the answers were good or not. So any answers that were not good were flagged and then sent for re-annotation.
Another quick question at all? We've got 1 minute. Yes, please.
So it's a matter of means people have shown that when you provide users with explainability techniques, sometimes they end up trusting the system more than they probably should.
Mhm.
So I'm wondering if you think that in the case of conversational systems that can lead to problems as well.
Yeah, I think it's definitely possible and a good avenue to look in. And I know one interesting topic for me is also scrutability. So they could see, since they have the explanation, whether or not they agree. So for example, if the bot returns something and they think their user scenario doesn't fit it, they should be able to tell the bot that that explanation is wrong and fix it. But yes, I think that the trust is definitely an issue worth looking into.